So far, we've covered mathematical operators. You may have learned of a new operation, the modulus operation, when we discussed those. Just got done talking about the relational or comparison operators, such as the greater than or the less than, will result in a true or false value. Now we're going to also look at logical or Boolean operators. Logical Boolean operators also will return a true or false value. Data that is true or false is known as Boolean after George Boole, who came up with Boolean algebra. He came up with all of this before computers were even invented. So he had the foresight to invent something that is used all the time now in computer programming. If you took CS 105, you learned about these 6 Boolean operators, not and or, exclusive or, nor, and NAND. In this class, we're going to focus on not and or, though you may want to consider the others if your programming gets a little more complex. Let's take a look at when you might want to use Boolean variables. Many times when you're programming, you might have a question that you can answer with yes, no, on, off, or true, false. If this is the case and you need to store the answer to that question, you can create a Boolean variable. To create a Boolean variable, you're going to use the keyword Boolean, that is the data type. When I create a Boolean variable, often I like to use an is or a has or a does in front of that variable kind of signifies yes or no. So I have, is Java fun? Yes or no, true or false. And of course it's fun, so I assign true to it. Is fish tasty? Of course fish is not tasty, so I've assigned false to it. So here's some examples of declaring some Boolean variables, and here's some examples of just, you can output it and it's going to output true or false, not with quotes, just true or false. By the way, if you use the printf statement and what you're going to output contains a Boolean value, you can use the %b placeholder or format specifier for anything in your list that's going to be Boolean. A Boolean expression is a Java expression that returns a Boolean value. Now let's think about what we just covered, relational operators. With relational operators, you were comparing maybe 2 numbers. So the operands may be numeric, but when you compare the 2 numbers, the result is true or false. So we can call that a Boolean expression because the result is true or false. Often Boolean expressions will end up being our conditions in loops and in if statements. Here we have a Boolean expression. Is x greater than y? Notice that x and y are ints, but 10 greater than 9 will return a true. Similarly, here we have x10. We're using the equality operator. Both of the operands are integers, but the result is true, so it's Boolean. I wanted to throw one in that's false. So is 10 equal to 15? No, this is a Boolean expression using relational operators. The result is false. Besides relational operations resulting in a Boolean value, logical operations can also result in a Boolean value. The difference is with logical operators and, not, or, the operands have to be Boolean. You can only and something that's true or false with each other. So you can't and a number with a number. You probably want a relational operator for that. Let's look at what I mean with some examples. Let's suppose we have a variable called gender. Let's say it's a string, and maybe it contains the value either male or female, and I know there's others. And that's either true or false for most of us. Well, it's true or false for all of us. We're either male or we're not male. And let's look at another variable called age, and that'll be numeric. And we're either 18 or not 18. But suppose you were writing a program in which you're supposed to pull up statistical data for all people in the US, and you need to pull up everyone that just turned 18 this year, so their age is 18, that are male, so their gender is male. And you need it for sending notification of selective service registration. Well, in this case, you've got two Boolean conditions. Age equal to 18, that's either true or false. Gender equal to male, that's true or false. If age is equal to 18 and gender is equal to male, they're both true. Does this person need to register? True. Do we need to send the notification out? True. If gender is male and age is 29, so I have a true condition and a false condition. If you are anding those two values, true and false is false. I do not send a notification out to that person. If the person is female, age is 18, I have a false for the gender condition and a true for the age condition. Again, though, I have a true and a false, and when I and them both together, I get a false result. So do you see that when you're doing an and, both of those conditions need to be true in order for the result to be true? Let's look at how OR works. Let's look at this example. A cruise has guests, and they get to meet the captain if they're in a grand suite, buku money, or they're a member of a diamond club, which means you've already spent a lot of money with that cruise line. So there's two conditions. Room type. If room type is equal to grand suite, it's true. If room type is not equal to, obviously that condition is false. And the other condition is Diamond Club member. That's true or false. Let's say someone is a Diamond Club member, true, but they're in a junior suite, so the suite type is not grand, that's false. Do they get to meet the captain? I've got one false and one true. If we're ORing that, only one of those conditions have to be true in order for the result to be true. So yeah, they get to meet the captain. What if they're not a Diamond Club member and they're not in a grand suite? Well, now I have two false conditions. ORing a false with a false results in a false. You don't get to meet the captain. In addition to relational operators resulting in Boolean values, there are also logical operators. The logical operators require that both of the operands be Boolean. You can only AND true false values with each other. You cannot AND a number and a number together. Different programming languages use different symbols for these operators. For example, if you're going to program in Visual Basic, you would literally write AND for AND. Java and many of the languages that descended from C use these operators. Two ampersands represent a logical AND. Two pipes, but they look like straight lines when you output them, represent the logical OR. By the way, the pipe on my keyboard is above my Enter key. I have to use the Shift operator to get to it. And then the exclamation mark is the NOT operator. I do want to say that the AND and the OR are binary operators. That means that you have to have two operands. Here we have X, let's say X is 17. 17 less than 5 is false, and we're ANDing that with 17 less than 10 is false. False and false is false. But we have to have a true-false value on either side of that AND. Same with OR. You have to have a true-false value on either side of that OR. The NOT, however, is a unary operation. It's like when you put the minus sign in front of an integer, it changes to the opposite sign. We're not doing subtraction, we're just changing the sign when you're using that minus sign as a unary operator. It's almost the same with the NOT operator. The NOT operator Doesn't change the sign, but it changes the Boolean value. So a not of a true expression results in false, and a not of a false expression results in true. What can you have for these operands? As you know, relational operations result in a Boolean value. So age this year is equal to 18. That's true or false. Age this year has to be a number. You're comparing a number to a number. Temperature greater than 50. That's true or false. Methods also can return a Boolean value. So gender dot equals male, true or false. And you can also use a Boolean variable. I have a typo there. Boolean has completed muster. So if I'm on a cruise and I've completed muster, that's true value. Boolean is a Diamond Club member, true or false. So I like to, as I said, for Boolean variables, I like to have it with has or is or does, so it implies a yes or no value. If you've taken a logic class, you might have done truth tables. So what a truth table does is a truth table works for a certain operator. Here's the truth table for not. So here is P representing either a true or false value, a condition, and the not of P. As we said, when you take the not of Boolean value, you just get the opposite. So if the value is true, not true results in false. If the value is false, not false results in true. The AND operator requires, it is binary. So we have P and Q here, and P and Q, there are 4 possible sets of values or permutations or combinations that P and Q can take. So true and true results in true. But notice true and false results in false. False and true results in false. False and false results in false. Real quick, we'll do the OR operation. So with the OR operation, it's kind of the opposite. So if any of these values are true, the result is true. The only time we get the false is if both values are true. Let's now look at this concept of short circuit evaluation. When you first start learning to program, you get the functional requirements and you make sure that you meet those requirements. Is your program correct? That is the aim when you first start programming. However, after you've been programming for a while, there are some non-functional requirements that you will start considering, such as efficiency. Is it a good program if it takes way too long to execute the problem? And the answer is no. Efficiency and robustness. Will the program fail if the wrong data is input? So even though it works with the correct data, when the wrong data is input and it fails, it's not a very good program. Short circuit evaluation is one way to increase efficiency because it allows your program to run faster. Think about it. When we're doing an AND, if one of the operands is false, the result is false. So with Java, we'll say, okay, I'm going to take a look at this condition that is being ANDed, and well, gender contains female. So I know this is false. I'm not even going to look at the age. It just says I already know this is false. Saves a little bit of time, but if it all adds up. With the OR, if one of them is true, so it's going to look at the first condition, and the weather equals rain. Oh, that's true. I don't need to bother to see what the temperature is because with the OR, as long as one of the conditions is true, the resulting expression is true. When you first start programming, one common use for the AND or the OR operator is to determine if the input is in a certain range. If I were going to write a program that inputs test scores, and test scores needed to be between 0 and 100, I would want to validate that the input was within that range. So range is a low to high end inclusive or not inclusive. It varies depending on the situation. So here's an example of the value x, and we want to make sure that x is between 20 and 40 inclusive. Notice one expression, x is greater than or equal to 20, that's the low value. The other expression, x is less than or equal to 40, the high value. And we're going to do a logical AND. So this results in true if x is in that range. Sometimes you want to check if the input is outside of the range. Normally, these two are opposite. So to test if it's outside of the range, you're going to use OR. Think about it. Can x be less than 20 and at the same also greater than 40? If you used AND here to test if x is outside of the range, you'll never get a true result, and you'll probably have a logic error. So use an OR when you want to test if a number is outside of the range. As I mentioned here, this is the example. I wanted to see if x is outside of the range. Don't use that and I hope you understand why you don't want to do that.